When you perform clustering on data, you want to divide the data into logical groups. What is the main objective of clustering? What characteristics do you want these groups to have? Let's take a look at the first of our unsupervised learning techniques, that is clustering. Clustering algorithms look within the data to see whether it can find patterns that will allow it to divide the data into logical groups. Items within a group are similar to each other, and items in different groups are different from each other. We'll study k-means clustering, which is a widely used clustering algorithm. There is so much data that is being recorded today that it all seems to be a big jumble. When you have data like this, how do you make sense of what's going on here? How do you make sense of the information that is contained within this data? One way you could get some traction to making sense of this is to group all of this data based on some common attributes. This grouping of data based on common attributes is exactly what clustering is all about. In this example, the data is actually files, and we've grouped them based on file types: CSV, MP4, XLSX, JSON, and so on. Now, the data and its attributes may not always be this straightforward. How would you find common attributes for products sold on Amazon, or people who are on Facebook, or websites which are indexed by Google? The number of entities present in each of these data sets is huge. And each of these entities are very, very complex. What if you wanted to group them? You have two problems here. There are too many entities and too many attributes per entity. The complexity is huge. There is a technique that you can use to get a handle on this. And behind that technique lies this insight. Anything, really anything in the world, can be represented by a set of numbers, provided you know what those numbers mean. In case of a product sold on Amazon, you could use the product ID, that might be a number, the timestamp the product was actually sold, and the amount the buyer paid for the product. Numbers that might be used to represent a person could be the age, height, and weight of that individual. And as for websites indexed by Google, you could use the length of the document or the frequencies of the various words that occur within that document. These are all numbers that could represent that site. Once you have the attributes expressed in the form of numbers, you can plot them on axes. Here, if you just have the age attribute, you just need a single line to represent the age of an individual. If you add another attribute in, you'll add another axis. So now you have the x as well as y axis with height on the y axis. And then your representation of an individual moves in this 2D plane. If you add in a third attribute, that is the weight of a person, then you go to three dimensions. A point on this 3D space accounts for the height, weight, and age of the person that you want to represent. You can extend these to n attributes. Each of these attributes will be denoted by a number, and these n numbers will represent a point in an n dimensional hypercube. Let's say you have a set of points in this n dimensional hypercube, and each point represents a Facebook user. The characteristics of each of these users are expressed in numeric form. Clustering involves grouping these individuals into logical units so that the people which are in the same group are similar to each other in some way. Maybe they like the same music, maybe they went to the same high school, maybe they like dog videos. The grouping should be such that individuals in different groups are different from each other. They're unlike each other in some specific way. You can imagine that Facebook would find it extremely useful to cluster users in this way, because by clustering users, you can target specific ads at them. If you have a cluster of users, all of whom have kids, you can send kid related advertising their way. Because all of these users are points in an n dimensional hypercube, the distance between the users is meaningful. The distance between users in a cluster indicates how similar the users are. The whole point of clustering data is to maximize the intra cluster similarity. You want data that is similar to each other to be in the same cluster. In addition, you want to minimize inter cluster similarity. Data that is in different clusters should be as different from each other as possible, as dissimilar as possible. And one algorithm that achieves this is the K means clustering algorithm. When you group entities into clusters, you want to ensure that all entities which are in the same cluster are very similar to each other, and entities which are in different clusters are different from each other. You want to minimize inter-cluster similarity and maximize intra-cluster similarity.